Hey everyone, in our third example of finding intersection, we have this question. So we have y equals to x squared minus 2x plus 1 over x minus 2. And the first thing to tell us is, well, before that, they actually had a few parts, and one of them actually is sketching, so I've already sketched it for you. But in part 4, they told you to sketch the graph of 9y squared equals to 9a squared minus a squared x minus 3 squared. So you might be very confused, right? Like, what is this equation? Well, yes, one way you can do is just put it in your GC. Don't forget your plus minus because you have y squared. Another way is maybe you want to recognize the state, which is actually faster this time around. So you have y squared and something like x squared, right? X minus a squared. So where have you seen such equations? Yes, the conics, right? So you want to get the y squared and x minus a squared on the same side as our conics. So we're going to do that. 9y squared plus a squared x minus 3 squared equals to 9a squared. Because it is plus, this would be either a circle or an ellipse. So what we're going to do here is, because we want to only get y squared on top and x minus 3 squared on top, we're going to divide by 9 and as well as a squared. So divide by 9a squared in total. Dividing by 9a squared, we have y squared over a squared. Then we have x minus 3 squared over 9, which is, well, what you should do if you are prone to making careless mistakes, is put in 3 squared. This will then give us 1. Alright, so we have an equation of an ellipse. Alright, of course it can be a circle if a equals to 3, but this is generally the general equation of the equation of an ellipse. So we're going to sketch that, and what we notice that the center is at 3, 0, and it is directly below the turning point of the original graph at 3, 4. So what we're going to do is, let's line up that center. And from here, because the number below x is 3, this ellipse is going to touch the origin just nicely. Alright, because the center is at 3, the horizontal distance, aka the major axis or the minor axis, depends on what a, but whatever it is, the horizontal distance would be 3, or horizontal radius, right, would be 3. So we'll flinched right there, so that came out of a bad one. Let me redraw that. Okay, if I don't shiver, I should be fine. Okay, fantastic. All right, so again, we have center 3, 0. So it's good to put your center down. And then we have the x-intercept at 0, 0, and over here will be 6, 0. Right, because it will have a distance of 3 from here to here and at the other side. How about the vertical distance or the vertical point? So this would then be A, right? So this from here to here will be A. So the topmost point would be 3A. But we don't need to write that down because it's not any intersection at all. Alright, so this is how we sketch the graph of y equals 9y squared equals to 9a squared. You can just write this original equation down if you're afraid, and then of course I forgot to label the original equation, so let me write it down here. Alright, so we get to this point. What's next? Now part 5, deduce the value of a if the equation 9x minus 1 whole thing power 4 equals to a squared x minus 2 squared 9 minus x minus 3 squared bracket has 3 roots. What an equation, right? So wow, why is this only x minus 1 power 4? Where did the x minus 1 come from? Well, if you actually look at your original equation, this is actually x minus 1 square over x minus 2, right? And then if you look at the right side of the equation that they want you to quote unquote solve, you notice that you have 9a square, you have, well, 9 minus x minus 3 square. So basically, if you notice, if you type in a square in, if you put in a square, you get 9a square and a square x minus 3 square as well. So this actually comes from your the ellipse equation. Alright, so if you kind of do some analysis, you realize that, hey, let's just rearrange this equation a little. You get 9x minus 1 power 4 over x minus 2 whole thing square equals to a square 9 minus x minus 3 square, which is the ellipse. On the right, you have the equation of the ellipse, the right side, and on the left, you have the original graph but whole thing square. And you notice that it's basically substituted the y equals to the original graph into the ellipse. Alright, so just to prove my point, you have x minus 1 square over x minus 2, this whole thing square, and this is basically your y that you've substituted with the original graph. Okay, so basically that's the whole idea. Now take a look at our ellipse. All right, our ellipse is bound to intersect the bottom. All right, the two roots at below the x-axis, right? So we have root 1 that's down here. We have another root that is down here, right? So that is 2. However, you always only get 2 for the 2 at the bottom there. You never get 3 at the bottom. So in order to get a third one, you must be intersecting right here. Here's the thing. You only want 3 roots, right? If you were to cross this line, it'll be, oh, I get 4. That's bad. If I come here, oh, it's still 4. Any higher is 4. But remember, 3, 4 is the turning point of the graph at that region. So you just want the ellipse to just nice touch the turning point. Alright, that's the whole logic behind this. Now, to solve the question, they want to solve for A. What is the significance of A? The significance of A is basically the idea of ellipse, right? Where A is under y square is over a square. A is the vertical distance from the center to the uppermost and bottommost points on the ellipse. So A is basically this value here. So as A increases, you notice that you stretch. Your ellipse will keep going up and away, right? But here you only want the ellipse to stretch and just nice touch this point here. So very simple. What is the distance between this particular point to your center? And that will be the value of A. In this case, because the center is directly below the turning point, we have A equals to 4. And that's how you deduce the value of A that solves that equation with 3 roots. Alright? So this is the one idea. It's the idea of, it's not exactly a radius for the ellipse because ellipse has no radius, but it's sort of a common idea, right? You're looking at how the circle or ellipse will expand. Alright, for circle, you're looking at the radius, so we expand proportionally for all sides, but for ellipse, maybe just one side. In this case, the y side. Alright, so circle or ellipse expand. Alright, so this is the third type of intersection questions that you might get with a third technique learnt.